Hi everyone, today we're going to talk a little bit more about Kafka. Now, in our previous video, we talked about Kafka at a high level. We talked about some of the basic concepts of Kafka, such as consumer and producer, and some of the other key information you need to know before going a little bit deeper into Kafka. So, just a quick recap of what we did in our previous video. We had producers which produced some data that went into Kafka, and then consumers connected to Kafka to consume that data or to manipulate that data in some other way and maybe go and send that back to Kafka again, and for it to be consumed by another different producer. And that's the idea of a pipeline, and that's what we talked about in the last video. And we also mentioned, when we talk about our producers, these can be applications and these can be used in any language, in any framework, and our consumers are exactly the same. They can be created in any language using any framework, and we can have multiple producers, or we could have no producers. If we didn't have any producers, it wouldn't make much sense, but technically you could have a setup or a Kafka cluster where you currently have consumers, but you just haven't set up the producers yet, and in that case you wouldn't have any producers, and the same for consumers. Right, so let's go and look a little bit deeper into Kafka to see what it looks like. So in this example we can see that Kafka has this idea of a broker, and we can see within the broker we have three different topics. We have topic 1, topic 2, and topic 3. Now, when we talk about Kafka and we talk about brokers and we talk about topics, it's important to maybe try and understand that while we have this diagram which has one broker, we can have multiple brokers. We could have 2 brokers, we could have 12 brokers if we wanted. And the same with topics. So we have 3 topics in this case, but this could simply just be one broker with one topic. So for example, you could have a broker, we'll call it broker 1, and you could have a topic, we could call it topic 1, but to give it a little bit more meaning we might call it email. So we have a topic, we're calling it email. Then you can imagine that all your emails, let's say, would pass through that one topic to maybe be analyzed by some of the other consumers. You could have a second topic, and you could have that as maybe SMS, or call it something like that, and maybe that's responsible with analyzing and dealing with text messages, so the content of text messages and what can be done in that. And then you could have a third topic, and you could call it whatever you want, and it could deal with whatever you want. It could be clicks, or trying to keep an eye on a database and maybe having a track record of all the updates or deletes, or maybe there's just a certain type of user that you want to track, or there's a certain group of users you want to track. That could be done by sending events to a topic either. So just looking at a little bit more detail, once we go into topics, we have this idea of partitions. So maybe to stick with the example that we used previous, we have one broker, and we'll take one topic, and we'll just call this topic 1 email. So we can imagine that this topic is going to analyze our email, and then we have partitions within that. So how exactly would a partition work within an email topic? So the way I like to think of it is a topic as or a broker as a database to some extent, and then your topic would be a table. So you could have an email table, but then the problem occurs if you want to go and have high availability with a table. What can you do to sort of split your table out to have good performance, so to have it scalable and to have it highly available? Well, you could shard your database table, and that's basically what partitions are doing for a topic. So you can think about a topic, so you can think of our email topic as like an email table in a database, and you can think about our partitions as just shards of that email table. We have 3 partitions as part of this email topic. You could imagine you would have you would split it whatever way you want, but you could split it simply on alphabetical order. So you could have maybe, let's say, the letters from A to, I don't know, F in partition 1, then from partitions F to whatever in partition 2, and then the last letters would be stored in partition 3. And you'll see why that will be important in the future in these slides when we have multiple brokers. It doesn't make a lot of sense at the minute because we would have all those partitions within the same broker. If we were looking at this diagram, we'd have our 3 partitions within the same broker. So if our broker went down, then we wouldn't really have much redundancy to go and get access to them partitions. But you'll see how it can be used now in a minute. So the next thing we want to talk about is multiple brokers and topics. So we can see in this diagram we have our Apache cluster, we have our producer and our consumer, same as last time, but this time we have 2 different brokers, which is quite common. It's common to have even more than 2 brokers, but 2 brokers at a base level for some type of redundancy. And you can see that we have this topic click, and we have the exact same topic click over on the right hand side in broker 2. Now the one thing to keep in mind is these 2 might not be exactly the same as far as the data that's contained within them might not be exactly the same. There's going to be, more than likely, one of them is going to be slightly delayed. Now it depends on what way you set up your Kafka cluster. You can have it set up that it will have both of them with the exact same information, but then to configure your Kafka cluster that way, you do sacrifice a little bit in terms of speed. So rather than it taking, maybe 200 milliseconds to just write to this first topic and then on broker 1, and then that same topic on broker 2 will be updated, sometime in the future, but we don't really care. If you want to have it, both of them updated at the same time, you would have to probably wait about twice the amount of time. So rather than having to wait 200 milliseconds, it might be 400. And depending on your scenario, that might be okay, or that may not be acceptable. Then when we look at partitions, so we can see this topic here is click, so we can imagine that this is monitoring some sort of click activity done by users. So it could be maybe clicks on a button, could be clicks on an image, or it could be clicks on a URL. And you can see that all these partitions here would represent them different parts. You could have partition 1 that would look at the clicks on an image, partition 2 could be clicks on a URL, and partition 3 could be clicks on something else, could be a button. And we can see in this diagram we have 6 different partitions. Now down here we can only see 3, but there would be 6 different partitions, and we have the exact same copy over here on our second broker. So it's just maybe something to keep in mind, or it's important to know that on broker 2 it's the exact same data, and in this case all the data is exactly the same. So let's pretend that broker 1 was the main broker and broker 2 was just a secondary broker that was copying the stuff that was done on broker 2. You could have a scenario where partition 1 has 5 different parts, and that's seen on this. Partition 1 has 5 parts. You could see partition 2 has 3, or it actually has 4 because it starts at the index 0, but broker 2 is the exact same. But then on partition 3 you could have 6 different parts, and on partition 3 on broker 2 you might only have 5 parts. So that would mean that this one is slightly delayed. So what exactly does that mean, or why do we care? Well, if you were an application and you were reading from broker 2 and not broker 1, then that means that the data you get would be slightly delayed compared to a consumer that was reading from broker 1. Or you could imagine maybe broker 1 goes down and then you don't have that additional data. So maybe there was an extra piece of data that was in partition 3 on broker 1, broker 1 goes down, then you don't have that additional data on broker 2 when you're reading from it, because broker 1 didn't get the chance to replicate it onto broker 2. This diagram looks a little bit complicated, but it's honestly not that bad. The only thing to keep in mind is we've talked about topics before. So we've talked about, you know, a topic could be something like an email, it could be SMS topic, it could be a click topic like in the previous slide. And we have this idea of leaders and followers, or it's often referred to as master and slave. So the idea is we have multiple brokers here. We have 6 brokers in this case, and for each topic we have the topics split over multiple brokers. So you can see partition 0 is on broker 1, and we also have partition 0 on broker 2. We also have a partition 0 on broker 3, and that's it. Yeah, so we have it on these 3 brokers, but broker 1 is the main leader and these other 2 are just followers. You can see they're identified as followers here. So this means that all consumers should go and read from this leader, because that's the one that has the most up-to-date information. But we do need additional partition 0s on other brokers, just in case this broker goes down or something else happens to it where it's unavailable to retrieve data, and then one of these other 2 brokers would get their partition 0 to be the leader. Then the next thing we want to maybe just look at is it's the exact same for our second topic. So we have a second topic here. It's called M2 for whatever reason, and we can see that it's on broker 6, it's on broker 5, and it's on broker 4. And we can see the leader is on broker 6, so the exact same thing. If broker 6 goes down for whatever reason, one of these other 2 brokers will be assigned as the leader, and then hopefully you have it implemented that it'll auto repair, so that another broker will be spun up and it'll make a copy of whatever that broker that went down had. So if broker 6 goes down, you want to spin up a new broker 6 with a partition 2 and a partition 3. But if it went down, if broker 6 went down and then it was spun back up, it wouldn't then become the leader. The leader would stay at either broker 4 or broker 5, whatever broker was selected to be the leader. So that's just something to keep in mind. Also, it doesn't switch back to broker 6 because broker 6 was the leader before it was killed. And then we've been talking about pub/sub or publish subscribe. We haven't really talked about queue-based messaging systems, and Kafka can do both. So pub/sub or publish subscribe is when we have our producers that publish some data to a topic, and then we have subscribers or consumers, and they just consume that topic by subscribing to a certain topic. So that's what we've been talking about so far. Now, the idea of messaging or queue-based messaging systems is slightly different, because you can see here we have multiple subscribers and they can all read the exact same data. So you can have this subscriber 1 and it can get and read the exact same data as subscriber 2 and the same as subscriber 3. But the idea with a queue is once a consumer grabs that data from a topic, it's gone, and no other subscriber or no other consumers can consume that data. So you can imagine maybe somewhere where this would be useful would be in microservices. So imagine you have some service and it's a producer, so it's producing some information. Again, we'll keep going with the emails. So maybe we've got an email that has to be sent out, right? So imagine you're Amazon or something, right? And you have an inventory service, and that inventory service will send a message to this queue saying that a particular user's order has been shipped, or it's out for dispatch. You want to go and send them an email. So what you do is you have a queue, and you would send the information such as maybe the product they bought. So maybe they bought a candle and the user was Ryan. So Ryan and candle, and other information such as their email address might be sent to the queue. And then you'd have many email services that would go and grab from this queue and would send out that actual email. So you can imagine that we have one consumer here. It grabs my order from Amazon, and it creates an email, and it sends that email out to me, and then that's done. And then it looks for more items in that queue. So maybe we have John, and John has bought something else on Amazon, and then that email is sent to him. Now you can imagine why we wouldn't want multiple consumers being able to read from this queue, because that would mean that for every consumer we have, so imagine we have 3 different email consumers that are able to produce emails and send them. That would mean every time that Ryan is put into the queue, Ryan would then get 3 different emails if there was 3 different consumers, or if there was 100 different consumers, then Ryan would get 100 different emails, and that wouldn't really, work. It wouldn't be a good user experience for Ryan, and it would be a waste of resources on Amazon's side. So we only want a queue to be processing information once, so that's when we have it dedicated to each different consumer. Now, there is something to keep in mind, that what if a consumer dies? Does that mean that that message is gone totally? No, not really. There's actually a little bit of a trick, and the trick is that the queue itself doesn't actually disappear, the information, as soon as the consumer consumes it, but it's switched to a state where other consumers cannot see it. And then once that has been processed successfully by the consumer, and the consumer sends confirmation back, then we know we can safely delete it from the queue. But if we don't get that confirmation back from our consumer, then that means that our consumer is dead, or something has went wrong, and we'd repopulate that into the queue for a different consumer to go and take it then for it to be processed. So, consumer groups, and how do these work? We have our Kafka cluster. We can see we have server 1, server 2, and then we have multiple partitions. So we have partition 0, partition 3, partition 1, partition 2. And the way this works is we have 2 different consumer groups, consumer group A, consumer group B, and each of these groups we want to be able to consume the exact same information. So we want the consumer group A and the consumer group B to both get the exact same information. But what we do not want is we do not want C1 and C2 to receive duplicate information. So at the consumer group level, we want everything to be the same. So consumer group A, consumer group B will receive all the exact information, but it will be processed differently because they have different resources. So you can see there's only 2 on this one. There's only 2 consumers, but while within consumer group B we have 4 different consumers. And we can see with this group A we have 2 consumers, and those 2 consumers are responsible for consuming 2 different partitions. So we can see C1, consumer 1 here, is responsible for partition 0 and partition 3, and we can see that consumer 2 is responsible for partition 1 and partition 2. But if we look at consumer group B, it has a consumer for each partition, so it's a one-to-one relationship. I hope you've gained some information from watching this today. Thank you very much for watching, and have a good day.